Welcome everybody. So yes, today we're doing simulation driven design. So let's have a look. So I mean, in the traditional, as it says, product development process, PDP, things like simulation, like FEA, were traditionally done at the end once the design had been, completed. An engineer might pass it to an analyst for validation. Okay, and then it moves to production, and then look if there was an issue with the design that the analyst worked out, then they'll go back, and it'll be a sort of potentially a slow process. Okay. The thing that this is pointing out that this is a late stage simulation, so this is performed by an analyst after the design is completed. The engineer or the designer doesn't really have any feedback as to what what if their design is satisfactory or not at that stage. This is, I guess, the traditional. I point out the traditional approach. When we do that, yeah, the issue is it's time consuming, costly to go through that process if it's a traditional process. But this is sort of showing you go to detailed design, you go to simulation, there's a design floor, you go back, okay, do the detailed design again, and there's another design floor, you go back again. So this is sort of just graphically showing what I was talking about there before. And yeah, it's like that cycle continues. It's done by multiple people, perhaps multiple departments, and the communication might be via email or some shared file or something, okay, which can take some time to update. I guess what we're looking at here is something a little bit different to that. It's sort of where the designer themselves can get some feedback on their design at the early stages of the process, so they can make the decisions themselves and take the decisions away from the analyst, and make decisions. Okay, a better sort of worse scenario. So simulation-driven design, it hopefully can allow us to, well, if we use it properly, I should say, it can allow us to perform, to end up with a design which is perhaps much closer to what is required, rather than having those multiple slow iterations that we saw before. So, if we have a look at this is pretty useful. So the y-axis here is the capability and complexity, and then if we're looking across here, we're looking at the time and expertise. Okay, so generative design is, which we'll talk about later, is about using some AI intelligence to help come up with a design for us that we might then tweak according to our situation. We have real-time simulation, which is what we would call in Creo terms Creo Simulation Live. That's part of an ANSYS technology that's embedded within Creo. And then we move on to a high fidelity simulation, which would be something like traditionally Creo Simulate, these days ANSYS simulation, or Creo ANSYS. Okay, so they're sort of done by that. And then if we're looking to get much more higher fidelity results, depending on what we're looking at, if we're looking at doing multi-physics and things like that, we might need to think about getting that analyzed by an expert or using some other technology. But this is sort of where we're sitting with sort of the Creo capabilities, and what we're really focusing on today is this sort of a really early part in the process that's trying to allow us to get something out that's pretty close to what we want, if not exactly what we want, early on in the process by ourselves, rather than having to rely on some sort of analyst. Okay, so this is just showing you here where this simulation driven design comes into play. Okay, and really, if I'm honest, it's more, this simulation driven design is more sitting in this range, what we're talking about today, because we're looking for more like instant sort of feedback. Okay, but if we have another technology, then like Creo Simulate, we can use that as well if we're a designer to get some results. So that's, I guess, why that sits there. Okay, so this is where that traditional simulation would sit. All right, so if we look at this page here, traditional analysis, if we look at that first, we need high fidelity analysis data to evaluate, optimize. Yeah, that's great, but it's for the generating the final design, and it can take longer, and it can, make sure we satisfy all the requirements. But often at an early stage in the design process, we're just trying to get something that is very close to what we want, and we're just trying to look at concepts and things like that. So that's where simulation driven design comes in. It can help us make those early decisions for our design without having to push it to a specialized analyst or someone externally to tell us that we need to change something. We can make that decision ourselves. All right, so if we look at within the Creo suite, if comparatively, so if we first look at the traditional analysis, this is things like simulation, which is Creo Simulate here. We've got fatigue and also something like answer simulation. So it's really high fidelity FEA or a mechanism type analysis. And that's sort of traditionally how it's done. These days, look, if you look down the list here, we've got a whole bunch of different tools. So today, what we're really focusing on is really Creo is simulation live and generative design. However, there are a lot of other tools that we can use for optimization and things like that, as you can see there. So kinematic analysis, behavioral modeling, and other areas. So if you have any questions about any of that sort of stuff, then we could probably handle those offline separately. But today, as I said, we're focusing on this, like the simulation live, which I think is applicable to most people, and then generative design, which is, I think, where things are going more and more in the future with AI.